start our first video of normal lectures, part 8.1, brief history of the internet. So we need to know some basic background before we can study the web programming techniques. All right, so this part, let's start to look at the, basic history of internet and the web. All right, first, so let's look at a brief history of internet. We do not want to, study too much background. So we only want to select the necessary part. First, we want to look at hardware part, the computer. The first electronic computer. So what's that? Approximately in that time from 1943 to 1944. So near the end of the World War II. So at that time, so there is a project called ENIAC, ENIAC, ENIAC project. So its meaning is Electronic Numerical Integrator and Calculator. So that C, you can see, so it is calculator. So not called computer at that time. So calculator, you may feel, so, small device, doing the basic math operation, calculation, like that kind of thing. But actually it's not. It's a big machine like this one. So look at, this is the picture of that ENIAC computer. So big. Okay, you need a big room to hold it. And you can see here from the picture, you can see it was built by, University of Pennsylvania. Actually, two professors there, did this project, ENIAC project. So these are the two professors. The first one called John Marchli. The second one called Presper Eckert. So these two professors, so they led a team and build this first, milestone computer. So that's the hardware part. Then we like to know the software part. So you need to have both the hardware, software, so then you can build the internet, right? So the software part, the milestone is like this. In 1969, there is a big milestone. That's the Unix operating system and the C programming language in Bell's lab. So that's the huge milestone from the software point of view. All right. Now, with these two, big cornerstones there, then the next thing, now we need to get to the network part. So let's look at the background of the network part. Still in 1969. Still at that early time. So that was the Cold War time, right? Cold War against Soviet Union. At that time, our enemy was Soviet Union. All right. So it is a big, powerful enemy. So they were very strong. So we have to really did a good job to win the war, right? All right, so the U.S. Department of Defense, DOD, so they did this project called ARPANET. ARPANET. So what's the meaning of this? ARPANET. An advanced Research Project Agency Network. The main keyword is this one, network. Yeah. So why this network is so special? Yeah, why it is so special? Yeah. The technical part, we will look at it in the next slide. Yeah. Very special network. Yeah. All right. So let's look at that part. All right. The internet was born. That milestone. Yeah. That big time. Yeah. And this is the picture of the team. Yeah. Yeah. So I cannot call the, list all the names. So we do not need. Yeah. So this team, yeah. They did this great thing at a time at this one, October 29th, 1969. Even the time is there, 10:30 p.m. So you may wonder why, how do people know this exact time, right? Because there is a big event telling us something really big happened at that time. Yeah. So let's look at the time. Sending a message through ARPANET. That was the time a message was sent successfully through ARPANET. That's the reason people use this exact time as the born instance. That instance, the internet was born. Yeah. All right. What kind of message? Yeah. So let me give you a little more information to describe that event. All right. A UCLA student. One student, UCLA student. Yeah. His name, Charlie Klein. Yeah. So this is a picture of that student. That student did this message sending thing that marked the, birth time of the internet. Yeah. All right. He sent a short message from UCLA computer to a Stanford computer. Yeah. In order to test this network really working, you need to send a message to a remote computer. The remote computer is at the Stanford University. Yeah. And what kind of message? Yeah. Very short message. Yeah. Only 2 characters. L-O. Yeah. L-O. Only 2 characters. So what's the meaning of that? Yeah. So the student, because for testing, the message itself is not important, right? Just you send something. Yeah. You send non-empty string to the remote side. That's good enough. Yeah. At that time, so the student came up with, something more direct, from logging, because he wanted to log into the remote computer. So log in. So he just picked the first 2 characters, L-O, connect to the remote computer. Then something happened. After he hit the enter key, something happened. So what happened? The remote computer crashed immediately. The Stanford computer crashed immediately. Yeah. Is that a good news or bad news? Yeah, it's a good news. Yeah, really good news. Because the message was sent successfully. The remote computer received message successfully. But the system was really bad. Operating system, the system running the remote computer was really bad. It cannot handle the message received from the remote computer and got crashed. But anyway, the message was sent through the network, ARPANET, successfully. Yeah. So that's the reason it was a big successful story. All right. Then there is a log of that event. So why people know that exact time? Because based on this log, this piece of paper in the log, yeah. So that specific time, then, here you can recognize the words target to SR5, the name of the remote computer, host to host. That's the log message, right? Yeah. All right. So that was the story for the big internet post story. Yeah. It was born. Yeah. All right. Then we want to look at the design requirements, technical aspects a little bit. Yeah, we will not go too much deeper in technology. Yeah, we just want to look at a basic idea here. Yeah. We know a network basically just connects computers, right? But when you connect large number of computers, you need some basic requirement. You need to have some good property for your network, right? So the biggest property, DoD people, operate, the designer. So those people, they want withstand attack from our enemy. We know we had a strong enemy, Communist Soviet Union. They may hit us with powerful weapon. We want to make sure our network still withstand the attack, still functionally, function well after the attack, even, right? How to get that property, right? It's not easy. Yeah. Here, the idea is like this. A very simple idea, but very effective idea. So what is that idea? Using a decentralized way to get a better resilience. Decentralized. So this word, I think, so you may hear of this word before, right? You may, you have many different chances to learn this decentralized idea. So why it is a good idea? It's very simple, so we can use some successful story to help us understand this idea. So let me use another example to explain this idea. All right. So why a decentralized system can control the damage. So we have a very good example here. Here we just borrowed idea from the military background. We have, very good example there. Yeah. So this aircraft carrier. Aircraft carrier uses this idea, decentralized idea, in some way. So what's that? Here. So look at the compartments. This graph, give us a, basic picture, telling you the arrangement of all the compartments inside a big aircraft carrier. So it has this function, isolate the damage by compartments. All sealed compartments. If one is broken, so water gets in one compartment, all the other compartments still, function well. So this simple idea So you can see we can borrow that, yeah, and use it in our internet, yeah, ARPANET at that time. Yeah. All right, so U.S. aircraft carriers have hundreds of watertight compartments, several hundred, yeah, that many watertight compartments. Okay, yeah. So that one weapon that might penetrate a layered defense is not likely to do great damage. Here, we use the function damage control, do the damage to the whole carrier. Yeah. So here, the network. Yeah. Each computer we treat as a compartment. So if, you know, our enemy hit several computers, you know, break, you know, certain number of computers, our whole network, the ARPANET, can still, you know, deliver the critical task we need. Yeah. So that's the basic idea. Yeah. Yeah. Here we use the reasoning by analogy. Yeah. And we try to implement this idea. Decentralized computer network. Yeah. So then this big idea is used in the internet, the ARPANET, the older name of the internet, ARPANET. Yeah. All right, then how to implement it, right? When you have a good idea, but how do you make it happen? That may not be easy. Yeah. So here we just try to get a little information of that. Yeah. We don't want to, you know, go too deeper in that direction because that's the content of a networking course. So not this, you know, first web course, entry-level web course. Yeah. So here, the main idea is this. Computers communicate with a network using a protocol, low-level protocol called a TCP/IP. Yeah, low level. Yeah. Because there are many different levels. So each level we may use different protocols. Yeah. So at that level, you know, very close to the hardware, that level, yeah, this protocol, TCP/IP, is used to handle the communication. Yeah. Okay. So that is a standardized way for communication. But the details of this TCP/IP, that will be covered in a networking course. Yeah. So, but here for this one, we don't need, for our web programming, we never need to touch that TCP/IP protocol. We never need to do that. We just need to deal with higher level protocol. Yeah. More specifically, this protocol we need to deal with, HTTP protocol. This big important protocol, HTTP protocol. Yeah. If I have some time, I try to give you some basic knowledge of this HTTP protocol. Okay? All right, so let me finish our first video, 8.1, in our formal lecture part A. Yeah. All right, yeah.